All right, so given that the winds are playing an important role on the surface ocean, let's look at what effect they actually have. So if we have wind blowing along the surface of the ocean, and it's moving in, say, a northerly direction along the surface, and this is the water column beneath the surface ocean, what happens is actually the surface waters, they don't move in the direction, the exact direction that the wind is blowing. It's kind of counterintuitive, but it's a result of this Coriolis effect and the frictional forces and the transfer of momentum from the wind down to the surface. And so what happens is at the surface waters are moving generally about 45 degrees off of the angle of the surface wind. And then beneath that, as we go down in the water column, the same effect applies. In other words, the force at a given level is transferring momentum down to the next level beneath that, and as a result of the rotation of the Earth and Coriolis effect, that momentum gets deflected slightly to the right in the northern hemisphere, and so what we get is slight deflection in this direction, and of course, because of frictional forces, we're losing momentum. And so as we move down in the water column, if we project this down onto the base, we start moving, currents start moving from this direction around to this direction in a lower manner. So the average deflection is about 90 degrees from the wind, and the direction of which it's either 90 degrees to the right in the northern hemisphere or 90 degrees to the left in the southern hemisphere due to that Coriolis effect. And so if we're looking at a map view and we take a look at how if the wind is blowing from south to north, then the net transport of water is going to be 90 degrees to the right, and so that's why if you ever get the opportunity to go to the Antarctic or somewhere where there's an iceberg floating in the water, the North Atlantic, for example, what you'll often see is that the icebergs are moving 90 degrees to the right of, or to the right or left, depending on which hemisphere you're in, of course, of the direction of the wind. And that's because of this Coriolis effect and imparting those forces down through the water. And so this has an impact on ocean circulation because the wind is moving in one direction and the water's moving in a different one. And depending on how that interacts with the different wind and current systems in the ocean, or the different coastal features, for example, we get different effects that impact ocean chemistry, ocean physics, and therefore ocean chemistry.